Hello guys, I'm back with another tutorial. This time we are going to cover some exciting topics like Solidity, Ganache, Truffle, MetaMask, and Web3 in general. So as you can see, I got the repository up and running already on my GitHub. And in this video, which is going to be two parts, we cover the backend and the front end of this PollStation application, which is a decentralized application. And the first step is going to be creating the backend, creating the smart contract. We'll write some code we'll write some code for the contracts in Solidity. Then we test those on the local Ethereum blockchain using Ganache. Then we deploy that on the Ganache. After that, we jump ahead and go to the front end. We will write the front end using React.js, and we will use the Web3 or maybe the Ether.js libraries to interact with our contract on the blockchain. And in the actually, finally, we hope to achieve something like this, which in this front end you could interact with your contract on the blockchain. So you could go ahead, connect your wallet, then create a new pool, something like this. For the first option, I'm going to use Notepad, then VS Code, then something like, I don't know, Atom, and I don't know, something like Sublime. And the title is going to be which, or actually, uh, favorite text editor. And then we create uh, the pool. We actually use our MetaMask. We will connect our application to MetaMask. We confirm this transaction, and as you can see, if you come in here, as you can see, our pool is created. And if we click on that, actually there's a bug in this. We'll fix that. And you could choose your preferred or favorite text editor. It's created by this wallet. And I will choose the VS Code, submit my vote, just like this. And as you can see, we voted for this one. This got the majority of the votes, and if we get back in here, you can see that the vote is registered. So we hope to achieve something like this, and I will keep you waiting no more, and we are going to deep dive into the code. So let's go ahead and do that. Okay, to get started, I'm gonna give you some introduction about the blockchain and how everything used to work before Web3 and how it's going to work when the Web3 is here. So let me show you this first. Okay, here's the illustration about the Web2 flow and the Web3 flow, which we are going to explain in here. I'm going to explain it for you. It's pretty much simple. You can get it, but here we got the front end, which is an interface designed or implemented using HTML, CSS, and JavaScript, and etc., and much more. And it's going to kind of request the data and receive the data from the backend, which contains a server, a database, and so on. Basically, these are the two main parts, and everything else goes under these two categories. So we got a server that could be written in everything that you could imagine of. Node.js, ASP.NET, Laravel, and go on. And we got the database, the user request to the server or to the backend, and the server gets the request. If it needs anything from the database, it's going to read it from here and returns the data or the data to the front end. But in the Web3, we don't have such thing as a database or the server. We could have something like that, but we should implement those kind of with the term decentralized. Then it's going to be kind of complicated. But in exchange, we got this. We got a blockchain over here. For example, we are going to focus on the Ethereum blockchain in this tutorial, and we got a blockchain which is able to run smart contracts on some virtual machines which are actually on the blockchain, and you provide those with some gas fee or with some Ethereum. For example, in this blockchain, and they have and you write some code which could be written in Solidity, Viper, Yule, or anything else. And when the front end is going to request something, it should kind of exchange data with the blockchain. But the data is binary, and you should request those in binary and will receive the data in binary. So in here we got something called Web3 libraries, for example Web3.js or Ether.js for the Ethereum. And those libraries will take care of the translation, kind of the data translation and request for us, so we don't have to transmit everything we want ourselves and translate that into binary or or things like that. When you create something, when you actually create a smart contract, when you compile it, it gives you an ABI or application ABI application binary interface, and these Web3 libraries read those and kind of gives us information or shows us how we could get the data from those contracts, rather than that we are the one who written them. So, and basically you request something from your interface. When you, for example, when you click on some button, it will tells the Web3 library to, for example, get me the username or read something on blockchain for me. These libraries will translate those requests into binaries or something that the end server or the blockchain or the smart contract could read or understand, sends the request, and the request gets back from the blockchain. So the flow might be the same, but there is some major changes, and the big one that everyone knows is that the blockchain is decentralized and cannot be controlled. Actually, it could be, there's some theories, but we're not going into those, and we say so they cannot be controlled in general. So I just wanted to show you this. This one will be on the GitHub, and you can get the photo yourself. So I'll close this one. To get started, we need, or let me show you something here. When we want to deploy something on the blockchain, in this case, we are going to use Truffle, which is this suitcase. We have something called Truffle suits, and Truffle is a pretty much handy CLI, could help us with some major difficulties. For example, first of those, when we want to deploy something on the blockchain, we could use Truffle, and the Truffle itself, which is a CLI. The Truffle suite helps us to compile, test, and deploy our smart contracts to the mainnet or even the testnet, or actually everywhere you want. So the first thing we are going to do is to install the Truffle by running this command. I already have it installed, so if I go here and type Truffle, and I don't know, V is going to give us the version or something, no, but the Truffle is installed here. So as you can see it, okay, we should write the version to see the version. And after that, after we install the Truffle, we need to go ahead and install the Ganache, this tool here. This one is going to create our local Ethereum blockchain for us, so we don't have to use the test nets on the internet or the main or the mainnet, which is kind of stupid to use for testing, because every time you are going to do anything or write anything on the blockchain, you should pay some gas fee. In order to do that, or testing purposes, we are going to install something called Ganache. This tool creates a local blockchain for us, like when we install MongoDB on our system or something like that, to get something locally for testing purposes. And each time we are going to deploy and test our smart contracts, we are going to connect to this blockchain, this local blockchain, and it will give us some test accounts, and we can use those, and it could provide us with some fake or local Ethereum. So we're going to need to download this one. After download, it's pretty straightforward to install. Just download and install it. After that, we are going to use it for our local testing. So we need this one. We need Ganache, we need the Truffle, and we need Visual Studio and some extensions in it. So next step is going to be create our directory. I've already done that in here. Our project is going to be divided in two folders. First one is going to be backend, And the next one is going to be front end, just like that. Here I will create a new repository, but let's skip it for now. I will create that later. In backend, we are not going to deal with the front end yet, but in the backend, I'm going to create a new or template Truffle project here. So I will open the command prompt here and type Truffle init, or sorry, init. When you press that, Truffle will go ahead and create a project for you. So let me see. Yes, we got the project in here. As you can see, we got some contracts here. Our contract here is in Solidity. And let me open this one in Visual Studio Code. Okay. We got the contract folder. This is where we are going to place our contracts. We got a migration. We are not going to deal with this one now because it's for the migration to the servers or mainnet or something like that. There is a test folder. All of our test files are going to be in this folder. We're going to obviously we're going to test our smart contracts, and those are going to be in this specific folder. So, and there's a Truffle config file, which there's a lot of comments in it. We don't need those. This is where we configure our Truffle suite. So this is where we tell the Truffle to deploy to which servers, which use which servers, the Solidity version that we are going to use, and so on. So I will create all of this. We don't need those for now. We will come back in here later and define some variables and some servers in it. So it's much cleaner now. After that, we're not going to use any packages here, but you could just go ahead and say like npm init to get yourself a package JSON, because there are some let me do it this way. There are some packages that you might need to import them in your project, and actually you could do this by npm, and Truffle will take care of that for you. So that's the good part of it. And I'm going to delete this, some cleanup here, and we can delete the migration here. We don't need this one for now, but let me grab this one, these two lanes here, remove this, and as you can see, I'll rename it test, and there you go. You got your Solidity contract in here, and you can start writing your smart contracts in it. So right now we need two files that are going to kind of two libraries that are going to contracts that are going to help us with some stuff. For example, the owner and the safe math. We are going to use those for some functionality in our program. So in our contract actually, and I will describe them for you when we go and when we need to use them. So let me go ahead and actually grab those. Spoiler alert. And paste them over here inside the contracts. And actually I'm going to remove this, or I'm not going to remove it right now. I'll do that later maybe, or when I change it. So after this, we got these two contracts here. Let's take a look at them. This is the owner. As you can see, it's going to help us, because when you deploy a contract on blockchain, the contract has an owner, and the owner by default is going to be the address that deployed that contract. So when you deploy a contract, you want to be able to change the owner maybe, and you want to have that abilities. And in some cases, as you can see over here, we have a modifier that tells us if it's the owner that's doing something. Maybe we want some functionality that only owner could access to those functionalities, and then we could use this is owner for that cases to determine is it the owner that's calling that specific method, or it's not. So and safe math is going to be used for as the name speaks for itself. The safe math is for trying to do some computational and mathematical operation on the unit 256. As you can see over here, I will tell you how to use it in furthermore. So let's go ahead and configure our npm or our package JSON to recognize some of our commands that we are going to use. For example, for the testing purposes, we want to, when we go ahead and type npm run test, some script, our project gets tested and compiled. So the test that we are going to write in here, we want those to be run and checked. So here we are going to define something like this. As I mentioned before, if you have Truffle installed and we have a Truffle project here, so you could go ahead and say Truffle and test. It will run it will deploy the compile, deploy the contracts, and runs the test that we defined in here. So I'm going to give this Truffle test inside in here because we are eventually going to manage this backend using npm. So I will say Truffle test in here, and for the development purposes, or let me see, for the compile purpose only, I'm going to create another command called compile and say truffle compile. Okay, just like that. It's might not seem necessary right now because we are only going to use these two options in here, but as you go ahead, you might need to add some more options in here, and that will make sense to do this kind of like npm management in here. Okay, now that we have these two, we could go ahead and write our first contract. So I will rename this one. Our application is going to be a poll application, so I will rename this one to the PollStation. PollStation. There you go. I expect you to have some minimum knowledge of Solidity because I'm not going to go in depth, depths for Solidity programming language. I'm just going to deliver the project and do the task. So I will try to explain those as far as I could, but I hope you have studied something about Solidity before. That will help you to understand this course better. Okay. And we could go ahead and configure our Truffle config in here, but I'm not going to do that right now because we are not going to deploy anything at the moment. For the PollStation, okay, first thing we are going to do is to create our contract. So I'll define a contract just like this, give it a name, so PollStation, and there you go. This is your name. This is where you write your contract's code inside this namespace, inside this block. And first things that we are going to do is just to define the create polls, because we are going to have some poll in here and we are going to need to create a poll. We could just define that poll in here, but that's not going to seem very clear. So I will create a new file called poll helper. It's a Solidity file. Let me grab these two. You should have a license over here and a Solidity version determination in top of your program. Otherwise, you are getting an error. Okay. In here, let me do this. Okay. In here, I will import the main two files, which is going to be owner. Oops. And actually it's going to be owner.sol and the file save math. There you go. After I will create the contract called poll helper. Everything that we define in here, we are going to inherit in this contract. So we could access to those properties, to those function modifiers, and etc. So I will get back in here. So basically, we are going to define two structures. First one is going to be the vote itself, and the second one is going to be the poll. So we have some votes which create a poll, and we have a vote list. We have actually, let's go ahead and define those, and I will explain those while I'm coding those. So struct this is how you define structs inside the Solidity. You just write struct, give it a name. I'm going to define the vote and define the properties of that struct. So first one is going to be address. Who registered this vote? We are going to use this to determine if someone voted for this one or not. Address, I will call this voter. Then we have a uint 8, which is going to be opinion. Which is the actually it's a number that determines which option the voter selected. Our application is going to be capable of polls that could go up to 32 options, minimum of 3 to 32 options. So uint 8 is going to be enough for us in this case, because this one is going to go, it's an unsigned integer from 0 to 256 or 5, I guess. That should cover for us, and keep that in mind for every storage, because these ones are going to be on storage on the you could define some values on the storage, and actually values on the storage on blockchain could be modified. So you cannot modify this program when you deploy it on the blockchain, but you can modify the values or the properties that are being stored in storage. So, and you actually pay for storage. Storage is much expensive than the memory in this case, in this specific case. And we have a uint 256, which basically is this uint. You can just write this, but if I press save, my extension will rename this one to uint 256. So uint, and this one is going to be date. It's as you can see, it will change that. It's going to be a Unix timestamp here. So it will determine who voted and when they voted to this. Then the next structure we are going to use is going to be the poll, and it's going to have an address, who's the owner, who actually registered this one. We have a string called title. We have a string list of the options, and we have a uint the expire date. Our polls are going to have an expire date, okay? And it will actually tells us when this poll is going to expire. The name speaks for itself. So then we have an insertion date. So let me remove the insertion date. We could use this to determine when this poll inserted and actually show some graphical information to the user. And the last thing we need is the vote counts here. So I'll grab this, paste it over here, and vote count. Okay, there you go. Keep that in mind. When you want to deploy this, our compiler will bundle this stuff, and if you put the same kind of types together, for example, this is going to be much more efficient than if we do this. Like I have a uint up there, then I have another one here, and there is something else between those. It's going to cost you more gas fees. You should keep that in mind, because when they are being bundled, they will take more space. So you want to unit or unify your values that or the types that are the same together, put them together. So we're going to move to the next section. We got our structs up and running. Next things we need to do is to use the safe math here. I will tell you how. Safe math is a plugin actually, and I'm going to use safe math for uint 256. So when you do that, you get access to some specific functions for this type. So let's say we have something like this here. Say it's called random number. It's equals to 2, and you can say random number dot add and add 2 to it. You get access to this one. when you use safe math, you get access to add, to subtract, and some basic mathematical functionalities. Then I'm going to define something called uint. It's going to be public. Public values could be accessed outside the contract. Yeah, so they are public, as the name says, then people could see those. Public total votes. We have another thing called, it's going to be uint 8, and it's internal. Internal values only could be called from the from other members of this contract, or the contract that inherits from this one. So they cannot be accessed. Sorry, they cannot be accessed outside the contract. When I say outside the contract, I mean when someone calls this function on this contract, they cannot access this directly. You can write a function which access this, but that function is inside the contract and it's calling that internally. Okay, it's expire after. It's a sorry again. It's a constant value that holds this one. Expire after. We're going to use this one to determine our expire date. So when we register a poll, we get the current date and add a number of days, which is 1 in here. If it was 3, it would have add 3 days to the expire date, to the current date, and would have set the expire date to that. So I hope you understand that, but if you're not, you will get a better grip at it when we are actually coding that. So we got 3 other uints, which are the same type, 8, and one of them is public. Move this down here. Another one is internal. This one is going to be max poll per address, or actually user. Keep that in mind. On the blockchain, your address is your identifier, which is unique to you, and there is nothing like username or ID when you use other systems. On Web2, we have something like user ID. We define databases with the unique identifiers and use those to determine a user from another user. But in this case, the address is the address that, or actually your unique identifier in this case. So a max pool per address is going to determine a limit for the users, that how much pool they can register. So if you are going, for example, to write some commercial polling app, you would set this to 5, and your users could pay like 0.0005 Ethereum to you, and they get one extra pool in their pool inventory, something like that, and they could like register 6 pools. So next one is going to be max pool options. This one is going to be, it's going to limit the options of a pool to 32. As I said before, it could go from 3 to 32. We're 3 is a static in here, but we could change that to this one if we want to. So okay, now we are going to define some mappings. Mappings are some kind of dictionary, kind of like that. You could access, you have a key and you have a value, you could access the values using the keys. So mapping address to uint 8, and this one is public, and it's going to be called address to poll count. So what's this one is going to do is you could do something like this. You could say, let's say we have a user address actually in here, or you could see this address as the user identifier. We give this one something like this, address to poll count. We say some address. Well, we don't have any address in here, so I will just type in address. And when you do something like this, or actually this one is going to be like this one, when you do something like this, this will return the poll count of this specific address. It will tell us how many polls they already registered here. So we could use this one to see if they have reached the 5 maximum polls or not. Another mapping that we need in here is pool ID to votes. So this one will get an uint. The pool ID is going to be a unsigned integer, and it will return us a list of votes. So I'll call this pool ID to vote. We could provide this one with a pool ID, and it will return us the list of the votes for that poll. Okay. Next one, we have a poll list which is public and called polls. Simple as that. And actually, you could access this one when it's public. You could access your polls. Everyone can see this, and that's a cool thing about the blockchains, that it's so public. They cannot modify it, and it's so public. Okay, now that we have our values and everything in here, I'm going to create a new function or method in this case, which is going to be isVoted. So function is voted. I will leave it in here for now. Then we have another function called isString empty. Or actually, let me just grab and paste the codes in here, and I will just explain you what's going on when they are happening. Okay, let's see what's happening over here. I have some comments over here. As you can see, we have a function called isVoted. Let me close this and close every function that we have here. We got some modifiers here, but no worries. I will explain those. And we have an event in here. So right here, we have a function called isVoted. We are going to use this function, as the name says, to check if someone voted for a specific poll or not. So we don't want someone to poll twice or more than once for a single poll. So we're going to use this one. And what this one is going to is, it's directly related to this one, to this vote ones, as you can see. So when you define functions on Solidity, you define those by a key or reserved word called function, as you do in JavaScript or other languages that you describe functions like this, and you describe the name in here. After that, you set the values or actually arguments for this function in here. It takes a address, which is the voter here, and it takes the poll ID. So it takes an address, who is voted, who are we going to check for, and the next one is going to be the poll ID, which poll we are going to test to see if this current address or this address voted for or not. So after that, you can see that we got three things here. In Solidity, or any other languages, you could define this. It's private, which cannot be accessed outside this contract, only inside this contract. This one is accessible, and it's a view. We got some modifiers here. These are called modifiers. So let's see, when you define a function in here, some function. Skip the arguments. After that, you could define the modifiers. So private is a modifier, public is a modifier. These are the modifiers. We have some modifiers called view, pure, or actually payable. Those are some modifiers that we are going to work with. And for now, view is a modifier that tells us you should use that for functions that actually reads and does not write anything on the blockchain. And the functions that are actually a view, they don't require any gas fees. You could use them and they don't require you any gas fees, because they are views. They are only returning some values and showing you some values. So this one is view, isVoted is view, and it returns a boolean. You should determine what's the returning value from this function. In some other languages, you do something like this. So for example, in C Sharp, you define the return value before the function in here. And in this language, you should define it here. So let's say our function returns a string, or I don't know, boolean, as in this case, it returns a boolean. And after that, you define the function's body. Okay, so that's the structure of the function inside the Solidity, and the error is because we are not returning anything, so return false, and you see the error is gone. So, and actually there's another error, so no visibility is validated intended to public. So yeah, actually you should define that. What is this? Is it private, is it public, or what? So if you say public, you can see that this one just fine. Actually, in this specific case, let me just tell you something. If this one was view, you should have got some error for the compiler. It would have complained about something that view variables or something. Sorry, the view functions are allowed to read the value from the storage, or the actually the state values variables that we have here. So, but we have something else called pure. When you name a function pure, or actually use a pure modifier on it, it's not allowed to read anything. It says that I'm not reading anything from the storage. I'm just doing some operations. Let's say this one is going to add something. So int x, int y, and in this case, we'll return the x and powers to the y. We return this. This one is pure because it's not accessing anything. It's not writing to the blockchain. It's not accessing anything, any value or any storage values. It's just doing some mathematics operations in here. But if we were to return the polls, for example, I want to return the polls here. So let's say poll, and it would return the poll list, and it doesn't take any inputs here. So this one cannot be pure because it's reading something from the storage or the state variable. So this one should be view. And if this is going to do something like, let's say, this is going to add something to the polls. So polls dot push. If this was supposed to do something like this, it wouldn't. It could not be view. It should be something else like that. Okay. So I hope you understand the difference between the view, pure, and other modifiers. It's time for us to move to the to this functionality. So inside the is voted, we are going to do some validation on. Let's say we are going to check to see if anyone voted it for the is the current address that we are passing in here as a voter has voted for this specific pool or not. So what we are going to do is we create a new variable which is going to be result. We will return this. After that, we get the poll counts with this. If you remember that, we define something like this. It takes poll ID, it returns the polls, or sorry, the votes. I said poll count, it's votes count. It returns the votes count for us. We get the length here. And if the poll counts is equals to 0, we return the result, which is false. And the reason is why, the reason is the following, because if it's 0, it means that no one has voted for that poll. So it should be 0. The is voted should be 0 because there is no vote. So this current address has never voted. Actually, no one has ever voted for this poll. So we should return 0. In the next line, we are going to create a list of votes here, and we will store those on the memory. There's two different places we could store variables. Actually, in Solidity, memory and the storage. When you define this one is on storage by default. We didn't write here like storage or something like that. Okay, it's by default is going to be on the storage, and when you write something on storage, it's going to cost you some gas fees. And actually, memory in this case is not going to cost you, and it's actually much more cheaper than the storage. So we rather to use the memory a lot than the storage, because it's going to cost us less gas fees. But in the Web2, because there was no gas fees for us, we should not pay anything when we are dealing with the smart contracts, or sorry, there was no smart contract when we dealing with the server or the UI. The person who created that website would have paid for anything that requires for that website to be up and running, and we don't have to pay for anything. But in this case, because there is no one maintaining this one for us, we should pay for everything that we store, or any calculation that we cause the virtual machines on the blockchain. We should pay those guys. Okay, so we are storing this vote on the memory, and we call it pool votes. It's a list of votes specified to this pool, and we are using this one, this pool to votes. So we pass the pool ID right here and get the results back. Actually, we could have saved that here. And in the next case, we are going to loop over it. So we loop over this this one over here, and check to see if the voter is equals to the address that we passed in. So if those are the same, we set the result to true, which means this guy has, or this person has voted already for this pool, and we return it. And if he didn't vote it, it will return the result. Sorry, it will return false by default. So this is how is voted call actually works. Keep that in mind. We could define some custom modifiers. So in this case, we have actually we don't have it already in here. We should define it inside the PollStation. We will create a new function called create pool. But in create pool, we are going to check to see if this person has reached the max polls for his address or not. So we use a modifier in here. We've defined a modifier which is here, as you can see, poll limit. It's modifier, it's not a function. So let's see what's votes once here. Votes once is a modifier that you could use, like in here you could say vote once and pass in the pool ID. As you can see, it will check and return if this poll ID, the person that's calling this poll ID, has voted. This causes the function to not run, and if it's not, it will run the function. So we're going to define some custom modifiers in here. Is a string empty is just a utility to check to see if the string is empty or not. We don't have the luxury of something like JavaScripts in here to check to say something like this. Yeah, if this string is equals to this string, you know, we don't have something like this in here. We should do some much more complicated stuff. So it's a utility that we are going to use to prevent the empty strings being passed. We have a compare string. It's the same. It's a utility that compares two strings together. As you can see, it's converts those two binaries and then encode them and compares the hash of them, I think. The next one is a modifier we have in here that uses this function that I just described for you. This one, this modifier takes an pool ID and it will check. Require is a way to throw errors on the Solidity. When your require fails, the operation just stops there, and the remaining of the gas fee that user paid for will be returned to him. So that's why we use require. And this one is a reserved kind of expression for the modifiers. When you want the modifier to continue, you type this. For example, when you're working with Next.js, you would say when you work with Next.js middlewares, you get a function called next, and you call it when your validation or anything is done. This one is the same for the Solidity. So, and as you can see, it throws an error. It checks the is voted. If it's false, it will throw an error for the contract data and stops the operation. The next modifier we have here is the poll limit. As you can see in here, poll limit will check this. As you can see, it will use the address to poll count, takes the message that sender. Message sender is a global kind of variable in here. When someone calls an function on the smart contracts, they should do that using a specific address, and those they should always do that. You cannot call a contract without using an address on the blockchain. So we always have a sender. And actually we have a message.sender, we have a message.value, which is the amount of Ethereum, or in this case Ethereum, or on other blockchains. It could be different cryptocurrencies, but the amount of Ethereum that's is being passed by this transaction or this value, which we are not going to work with in this case. So it takes the sender, pass that to the address to pool count, takes the pool count, and compares that to the max pool per address that we have here, which is 5. So if this one, if the address has already 5 pools, this will return 5 for us. And since 5 is not less than the 5, it will throw an error and said you have reached max pool per address. So there you go. And it's a modifier that we are going to use. Next is the validate pool ID, which validates to see if that pool ID is inside. This one is used when we are voting for a poll. So we are going to have a function called vote, and in that function we are going to use this modifier to see if this option is actually exist on this poll. So let's say we have a poll that has 5 options, and if someone tries to vote for the option number 12, there's not going to be a number 12. There should be an error. Says invalid pool ID. Actually, the description I just gave you for this one is going to check to see if we actually have that pool ID inside our polls list. So someone is trying to vote for a poll that doesn't even exist, or the pool ID is invalid. This one will throw an error. This one, the validate option, another modifier that we are going to use is this one will check to see if the option that we are going to vote for is valid or not. So it will take a poll ID, it will take an option, and reads the poll from the polls list. As you can see, we get the length, and here it will check that. So if option is greater or equal to 0, it should be actually 3. And if the option is less than the poll's options length, so that's it. As you can see, we get the poll here, then we get the options of that poll, and get the length of that. So if we have a poll that has 5 options, if someone tries to poll for the option, I don't know, 7, it should throw an error. So that's the next modifier. We have an event here. We will cover those when we are working with the front end. Just let me say that when you want to declare something, let's say someone voted for someone created a new pool, we will call this event, and everyone on the blockchain will be aware that someone called this. Actually, on the socket providers, you could get a real-time connection, and it's just like WebSockets. You will get a event, and you could change something on your interface. So, and there's another event which is new vote, same as this one. This is for the polls, this is for the vote. So this is our helper in here. We have a helper contract, as you can see, and we are going to use this helper contract inside our main PollStation contract. Now let's back to the main contract, which is PollStation. We are going to import our contract here. In this case, let's see, where's the problem. There seems to be a problem with our code here. Let's see the problems. Yeah, I misspelled this one. So address, the pool count, yeah, it's count. It should fix the problem. And max polls per address, I misspelled that too. So max poll, yeah, I said max polls, it was plural. So the problem is solved. Right in here, we should import the poll helper. So .sol, and we are going to inherit from this contract, so we can have access to the values and the functions from this contract. So to inherit in Solidity, you just go ahead and say contract PollStation is, and type the desired or the target, which is this one. So poll helper. So now in here you can access these values, these functions, these modifiers, these the variables that we defined here, these structures, and everything that we have in here, which is public or internal. So inside the PollStation, now that we have our main functionalities inside the poll helper, we are going to create our main functionalities, which is creating the poll, getting the polls, voting for polls, and let's see if we have anything else. Yeah, we are going to vote. We are going to get the polls. We are going to get a single poll and check to see if someone has voted for a poll or not, and actually creating the poll. So I will go ahead and copy paste the codes that I've already written. Yeah, I'm just doing this for the sake of tutorial being short, because we have a lot to cover on the other side. So there seems to be a problem here. Max poll option, this one is wrong. Max polls, it was plural, so yeah, there you go. They should be max poll. Is that right? It's plural, so max pool options. I saved this. This should be fine in here. Yeah, it's fine. The error should go away. So as you can see, the error should go away soon. And there you go. We got our main code here. So we have a main function here called create a poll. We will use this one to create a poll. In here it takes a string which is on memory. Keep that in mind, it's very important. Called title. To create a poll, we need a title. We need options, which is a list of strings, and that's going to be on the memory too. It's public, it's payable. When you write something, when your function writes on something on blockchain, your function should be payable. You should mark that as payable. And it uses a custom modifier called poll limit. So let's see what's this one is going to do. Poll limit is here. Let's see it. There you go. Poll limit. What is going to be? What's this one is going to do? As I said before, it's going to take the address, which is the msg.sender, and gets the poll count of that address. And if it's less than the limit that we've defined, it will let it through. And if it's not, or it's equals to that, it will throw an error and says you have reached max poll per address. So that's how you use the modifiers. Inside the functions body, we are going to check the title to see if it's empty or not. And if it's empty, we throw an error. The next one is going to be to check the options if it's going to exceed our limits or not, which is 3 to 32. And the next thing we are going to do is to create a new poll. So we are defining a time here. We take the block, the timestamp, and blocks on blockchain. On Ethereum, I think the blocks are wrapped every 17 seconds or 10 seconds. I'm not sure. They're being wrapped and registered on blockchain, so you cannot get the exact time that the code is running, but you can get the time of the next block that being mined. So block the timestamp, we get that. It's a Unix timestamp. And we create a new poll here. So we have a structure here. So when you are going to define a new structure, you just go ahead and say like poll and pass in the values. So if you remember, our poll has an owner, which is the address, title, options, insertion date, expire date, and the vote count. So the address is going to be the msg.sender, or the one who calls this contract. It's going to be owner of that poll. The title is the title that the user passes here. Options is the options that users passes here. And let me remove this. And the next one is going to be the time plus expire after powers to 1 days, as I told you before. So as you can see, days is a constant in this global constant reserved name or word in here, which I think it's the milliseconds of milliseconds, how much milliseconds is in a day. So you can actually use this and kind of create the dates. You got days, you got years, you got month. No, you don't have month, you have day and hour, I think. Yeah, we got hours and minutes and seconds, as you can see. These are the reserves one, and you can use them. Keep that in mind that I'm using an extension called Solidity, if I'm not mistaken, because Visual Studio by default does not support Solidity. Yeah, I'm using this extension by Johan Blanco, and that's why I'm getting this kind of syntax, coloring, and stuff. So now that we have this, we have a pool. We're defining a pool on memory, not on storage, called pooled, just like this. Then we push that into our public pools, which is here, which is public to everyone. Okay, on the storage. This one is on the storage. So after that, after we've done that, we fire the event in here. Event takes the same arguments as this one, as you can see over here. It takes the same arguments and it will fire the events. And the next thing that we are going to use to actually do is to increase the pool count of the address. So we add 1 to the addresses pool count. So the next time that this address is going to register a vote, if it's reached the kind of a maximum pool per address, we should throw an error. So we could actually validate that. After that, after this function is done, we get to a function called vote. It's external. So external only could be called outside of the contract. You cannot call this one from inside the contract. It's external function. So this one is payable too, because we are writing something on the blockchain, on the storage. And this one has 3 different modifiers. First one is the vote ones. It will check to see if this specific address has already voted for this poll or not. The next one is going to check the to see if this poll ID is valid or does even exist or not. And the last one is the validate option, which takes the poll ID and the option ID and validates to see if this option is valid or actually exists or not. So the procedure is the same for the votes, or sorry, it's not the same, but you can already guess that by seeing the create poll. It's kind of basic. We are going to get the polls, or sorry, we are getting the votes for this specific poll. As you can see, poll ID to votes, we pass in the poll ID. We get a list of polls. We get a list of votes for this specific poll. We push a new vote in it. As you can see, push the new vote to polls votes list. Then we increase the votes count. So inside the polls list, we get the poll ID, or sorry, we get the poll that we want, and then the votes count is going to be equals to poll ID dot votes count dot add to 1. This one is being added by using safe math. So now that we are using safe math in here, this one is being added right in here. So after that, we emit the new event for the new vote, and then we increase the total votes count in here. So that's it. Next step is going to be the get polls. This one is, as you can see, it's external, and its view is it does not write anything. It does not require any gas fees or anything like that, and it returns a list of polls which is on the memory. And as you can see, it only returned polls. It does not do anything special or something like that. Then we have the get polled votes. As the name says, we get the vote list for the specific poll ID that we pass in. So this one is external too, is view, because it's not going to change anything. It's just going to return something, and it will validate the poll. So it will check to see if this poll ID is valid or not, and returns a list of votes for us. And as you can see, it uses this mapping pool ID to votes with the pool ID that we passed in. Next one is going to be the get pool. It's just the same as this one, but this one does not return a list of pools. It just returns a single pool. Next one is the vote, has voted function, and this one takes a poll ID. It's external and returns a bool. Actually, you can't return more than one value out of a function, and that's one of the cool stuff about the Solidity. You get two values out of this. So this one, as the name says, checks to see if this current address that's calling this function has voted or not. So as you can see, we have a boolean called voted, which is false by default, and we have a option here. So this one is going to be the if this address has poll voted for anything, for any specific option in this poll, this is going to be that option. This field gets returns, because when on the front end we are going to show the user if they have voted for a poll or not, and actually determine the option that they've chosen. So we get the list of votes here using the same mapping that we used before. We're going to loop over it, over the votes, and check to see if the voter is equals the sender of, or the caller of this function. And if it's that's the case, we set the voter to true and set the option to the opinion of that specific vote, that the messenger is equals to the voter of that. So, and then we return those. So if he is voted, he gets the option that he chose, and the vote is going to be true. And if he never voted for this poll or anything like that, the voted will be false and -1 for the result. So as you can see, it's our contract. We got our contract up and running. There seems to be a problem, so let me see. It says vote count not found or visible. Look, no problem. Okay, I think it's the typo, or sometimes the compiler complains about something, but when we compile, actually it's going to be compiled. So let's go ahead and test it actually. So in here I could go ahead and say npm run compile, and if you press enter, you can see Truffle will start to compiling our contract for us. And if there are any errors, yes, there you go, votes count not found. So there should be problem with the, yeah, it's vote count. It should be votes count. If I save this, the problem should be gone. And if I run it again, our contract should be compiled and be inside a folder called build, if I'm not mistaken. Yes, there you go. There you go. Our contract is compiled, and as you can see in here, we got our stuff in here. This we are going to use this stuff and feed those into our Web3.js libraries, as I told you before, and they are kind of the interface that tells us what kind of functions are available on these contracts, and what kind of actually functions or the variables we could access, and how to access those. So if we go and take a look at this, it's going to be a long file, as you can see, and it's just auto generated, and we don't have to deal with this. As you can see, this is the API of this. So we'll close this. As you can see, we have created our contract. Our contract is ready, and we could go ahead and start the testing of this contract. So let's go ahead and do that. So in order to test our contracts, we're going to head into the test folder and create a new file called, actually you can call it whatever you want. I'm going to call it like poll and vote and david.js. Inside this file, you could start actually interact with your contracts. This is one of the Truffle's features. It allows you to test your contracts, deploy them, then test them. It uses, if you refer to their documentation on their website, you could see that Truffle uses the Mocha and the Chai and you can actually follow those guidelines inside your testing process. So in order to test that, we need to import and create an instance of our contract. So we're going to go ahead and type const PollStation artifact, and it's going to call the artifact that require, and the name of the contract, which is PollStation here, just like that. And we got the artifact in here. Then we are going to create our contract, just like this. Contract, name of the contract, PollStation, and we passed in some accounts. Actually, when we test our contract, the Truffle will gives us some accounts to actually interact with our contract. So in here, we are going to actually get I think it will return somewhere around 10 accounts. We are going to use 2 of them maximum. So const account 1, account 2. We are going to destructure them from the accounts. Equals to counts, just like this. Now it's time to write our tests, but before that we should actually create the contracts. My bad. So PollStation, here, this one. There's a function you could actually, it's kind of hook you could use inside the Truffle, which is before each, just like this, and it will run the code you put in here before each test. So we're going to need to declare this one, actually initialize this contract, and we need to do that before each test. So we use this, it's going to be async, and just like that, and it's going to be PollStation is equals to wait and PollStation artifact dot new. It will create a new one for us. So just like this, we created our instance of the contract. Now we can just go ahead, like, let's say we have something in here inside the PollStation, public methods. One of them is vote. It's actually external. So you could just go ahead and say PollStation dot vote. You can do something like this. So we have the contract instance in here. Now it's time to write our test. So some descriptive information in here. So it should be able to register a poll. We're going to test to see if we can register a poll. So to register a poll, and the codes are going to be inside here. So first of all, we are going to get the create a new poll. So it's going to be poll ID. It's going to be equal to wait, because the function on this are async. So PollStation dot create poll. If you come back in here, you can see that this one is public and we are accessing it through our contract, just like this. So let's see what inputs we need. We need some title and we need the options. So let's get back in here, and for title I'm going to say what is your preferred text editor. You could actually put anything in here. And for the next item, I'm going to pass in an array of options. So first one is going to be I don't know, VS Code, not bad. Not bad. Second one is going to be Visual or VS Code. And last one, or the next one, is going to be Sublime. And for the last one, I'm going to use Atom. And just like this. So the next step, actually, let me show you what happens when we run this one. and I'm going to actually print the results in here. So I'm going to rename this one to create poll result. So, and I will console log it. So poll res and create poll res and just write this one. So now we are going to come here, see the backend, and npm run test. Let me check this one. Package JSON. Yes, we got this. So, and if I press npm run test, let's see what happens here. It will compile the contract, store the artifacts in some temporary places. It will not update this build, this folder. So, do we have an error here? So, wait. Yes, this one should be async. It should work now, actually. And there you go, the contracts are compiled. And yes, it did create the poll, so the test just passed. The purpose is fulfilled. And if we come back in here, you can see that this is the result that you get from an transaction on the blockchain. It's actually a transaction result here. So what do we have here? The transaction hash, the receipt. Receipt contains the so much valuable information for us. We got the logs, we got the events that occurred, and etc. So actually you could come in here. Let me see. There's a status. You should check this. If the transaction is successful, this one is going to be true, otherwise it's going to be false. So you should actually check this one. So now that we have this, let's see what information we can gather from this result. So let me minimize this one and come down here and actually comment this one out. We're going to get the title. We have the title here, but we're going to see that do we get the title from the results, because when we actually create a new poll here, let me see, you can see that we call an event here. So we emit a new event, and if we go to new poll right in here, you can see that we emit some stuff in here: poll ID, the title, the options, start date, and save date. So let's get back in here. Title is going to be, so we can actually read those values. So title is going to be poll create poll res dot receipt. Actually, let me grab this and remove this, and is equals to, or something like this, equals to create poll res. Keep in mind that this could be empty, I think, if the transaction is false, but I'm not going to deep dive into that right now. So we're going to get the title is equals to logs receipt dot logs and argument. If you can see it here, you don't get the specific information from here. See, we go into the logs, then we go to the arguments. As you can see, that's where our events arguments are stored. So as you can see, we got a new pool event called here and actually written down in here. So args and dot title, or let me print this one out first so we can get a good glimpse of this. So if I print this, let's see, logs or args, and let's run it again. As you can see in here, this is the logs that we get inside the logs. So the first one it's going to, you can actually access them by index or the name of them. So we get the title, we get the options, we get the expire date. It's a big number, so keep that in mind. And actually, let's write something down using this stuff. So I get the title, I get the options. Actually, as I said before, we have them here. This is just for checking purposes. So let's see it. Options, and we can now come down here and type something like uh, console.log and no poll, and it's going to be title and options inside in here. And if you want to get the poll ID, you could do something like this. So and actually we should parse this one. So poll ID is going to be in here too. So let's run it again. Okay, as you can see, oh, I forgot to comment this one out. So as you can see, we get the new poll. The poll ID is 0. That's fine, because if we create another one, it will be 1 and so on. So the first step is working, creating. We could actually create a new poll. So if you want to test other stuff, you could just go ahead, create like 4 or 5 polls, and when you to check to see if you reach the max level of the polls. So and we're coming down here and create another test, and this one actually should vote to a poll, to a created poll. So I should type in here something like, it should be able to vote using 2 different or 2 different accounts, and it's going to be sync. And you could actually check it. The purpose is to be able to vote using 2 accounts, but you could check to see if you can't actually vote for the same poll twice or not. And we are going to implement that in the next section. So in here, you should not be able to vote for the same poll twice, just like this. So let me grab this one, and right down here we're going to check. Actually, we could check it, we could not check it. So I will comment or delete this one, go back to these two, and if we need the other tests, we will write them down. So in order to do this, first we need to create a new poll. I'll grab this one here, and let me actually copy this, bring it up here, copy this, paste it over here, remove this. Now we have a new poll, and we have the poll ID in here, so we can actually go ahead and vote for this poll ID because we have it right now. So now I'm going to create something new called, let me see. Yeah, we're going to vote, so it's going to be const vote res equals to wait PollStation dot vote. So let's see what inputs do we need here. So vote, we need the poll ID and we need the options. So the poll ID is going to be this one, and I'm going to vote for VS Code, which is the second option, and it's zero index based, so it's going to be 0, 1, 2, 3, 4, 5, and so on. So I'm going to, this one is going to be 0, and this one is going to be 1. So just like that. And let's just print out the vote res here. Console.log vote res, and like this one. So if you're going to skip a test, you could just place an X in front of it, and this one will be skipped. So, and I'm going to skip this too. We want this one to be run only. So let's run it again. As you can see, the first one gets skipped, and we have a failure here. So what's the problem? So it's not defined. So yeah, that's right. We need this too. So let's run it again. Okay, we got another problem here. So invalid option. We got the reason here. We got the invalid option. So invalid option should be coming from poll helper. Yes, invalid option. So invalid polity, yeah, an invalid option, because the option should be greater than 3 and less than poll length. And the problem seems to be from here, because it checks it. We are passing something like this. We're passing 1 in here, and it's obviously less than 3. So the logic here is wrong. It should be greater than or equals to 0. Basically, it should not be less than 0, and it should not be greater than the polls option length. So let's save this one and run it again to see if we get the error again. So after that, we are going to check to see if it has voted. We are going to use this function. So there you go. We got everything up and running. It got skipped, and should be able to vote using 2 different accounts. Did we actually do that? No, we haven't. We just voted using 1 account. So we are going to fix that in a bit. So let's see what we got here. We got actually the same results as the last one, the received. We got everything from the last one, and the status is true. So if we get any errors or any options, we get a result right like this. We get the reason as we defined in the require inside the Solidity contract, and if it's passed, then there you go, you get this one. So I will remove this. Actually, I don't want this to be here. After all the testing, you should remove the console logs, because you actually want to see this. You don't want to see whole stuff in here. So now I'm going to vote using another account. In order to do that, in here, you can see that we voted without specifying which account we are, or actually which kind of, the accounts are private key on the blockchain. So which account are we are using to vote and actually sign our transaction. So this one is going to use the default account, which is going to be account 1, I think, right here. So I'm going to, let me actually get account 3 and account 4 and account 5. We're not going to use those, but they might be handy in here. So let's copy this, vote res 2, and in order to specify which account we are going to actually call this method, we'll pass in an object and specify the from. So from is going to be the account. We are going to vote using account 2. And as you can see, just like this, I'm going to save it and run the test again. When the test is done, it should be you should vote for the account, or sorry, vote for the poll using the first account in here and vote again using the second account. After that, we're going to test to see if we can or cannot vote using the same account for the same poll twice or not. So there you go. We got the results in here. It's working. There's no problem, but should not be able to vote for the same poll twice. So let me grab this, paste it here, and I'm going to repeat the process here. So I don't need the results. I'm just going to call the vote again using the same account. So let's actually remove this one from the pendings, or unskip this and run the test again. And the first two are skipped, and we should actually get an error here. So there you go. We get the error. The reason in here is specified. You have already voted for this poll. So please, that's actually tells us that the contract is working well. It's failing in here because there's an error, but this one tells us that the contract is working because we don't want people to be able to vote for the same poll twice. So actually, it's kind of working here. So, and basically, the testing is just the whole process of calling the functions, check to see if everything works fine as expected, because once you deploy your contract to the blockchain, you cannot change it. So you should make sure to write and test everything properly, so you don't have to change your contract's address every time you want to make a change, or because you made a mistake writing your code. So make sure you check your or test your code probably, and actually your contract probably. Now that the contract is written, the functionality is tested, we could go ahead and deploy, or actually deploy our contract on the blockchain. In this case, we are going to deploy the contract on the testnet, on the local testnet, which is going to be Ganache. So let me run the Ganache first, and meanwhile we could check the Truffle config. We need to specify the Ganaches for the local testings inside the networks. We don't have any networks, so Truffle don't know where to deploy or where to actually test and deploy or migrate our contracts on. So in order to do that, we should come inside the networks. I have the configuration already copied, and I will paste it here. So we define the network name in here. After that, there is an object which contains the configuration, the host, the port, and the network ID. So when we do that, we're ready to go. So in here, I already have a blockchain. I will use this one. You can create a new one, new workspace, something like that. I could go ahead and create a new one, but I will use this one. When you click on that, you could create new one. It doesn't really make any differences. So we wait for the Ganache to start the blockchain for us, testnet blockchain. As you can see, it gives you some accounts. It will generate some accounts for you, and actually you could use these accounts on actually everywhere you want, because you have the private key in here. If you click on this, you can import those in MetaMask or any wallet manager or something like that. So we have our blockchain here. You can see the transactions. Actually, there is going to be a lot of transactions because I was testing on this blockchain, but when you create a new one, there's going to be no transaction log in here. So, and let's go back to the accounts right in here. And now that we have the configuration here, we could just do something like this and say npm run test, and as you can see, it will start to test our contract again. But this time it's going to use the network development, which is this one. So let's see, go into the transactions. We have an error. Yes, you have voted for this poll, but that's not the reason we are doing this. We don't care about this one right now. Or actually, let me fix this first, or remove this one for now, or actually skip it. And when we come back in here, you can see, if you scroll in top, you can see that we got some contract calls, and these calls are basically this calls that we do in here. There are actual transactions. They are here. When we call this, we create a new transaction and new blocks on the blockchain. So if you go back in here, we see a contract creation. This contract is exactly this contract which is deployed on the blockchain. So if you click on this, you see the contract's address. See this? And you could use this address on your you could feed this address to your Web3 or Ether.js library in order to create a new instance of this contract. So actually, we use the test. When you use the test, it will every time you use the test, it will deploy the contract to the blockchain or test blockchain in this case. But in order to finally get the last version of this, you should use the migrations, which we are not using in here right now. We are using the test, but you could achieve testing purposes using the test and get the contract address from here. So now that we know how the test works and how it actually kind of interacts with the blockchain, we are going to use migrations, because at the end we need to use a migration to pull the last or actually kind of deploy our contract to the blockchain, not when we are using test, because when we're using test, it will deploy it each time on the blockchain, and we don't want that. We want to, when we're done with our contract, when it's written and tested and everything, we are going to deploy it to the blockchain. After that, we get the address. That address is going to be same forever. Keep that in mind. We get that address and use that contract's address inside our front end. So the next step after this, after going through the migration now, the next step is going to be going and jump into the front end, because after that we created our contract, we compiled it, we tested it, and we deployed it to the blockchain. So there is no interaction, or there is nothing to be done with the backend. We should jump into the front end. So for now, we are going to go into the migrations, create a new file, and migrations should be started like this. You should number them because they will be run in a sequence. So init like I'm actually going to call it init. You should be more descriptive in here, so initial migration or something like that, but I will just call this one init. I'll paste the code in here. It's a simple code. It's exactly the same as the test, as you can see. First we get the artifacts, as you can see. Then right in here we export this function, and there's a deployer, as the name says, and using the deployer and the deploy function on it, and then we fit the artifact to it, and this one will migrate the contract for us. So if I save this and go in here, and actually we don't have the migrate inside the package.json, you could go ahead and type truffle migrate or define it in here. Since we have everything in here, I'll define it here. So migrate, and there you go, and there should be npm run migrate. And if you press enter, it will compile the contract, then it will deploy it. So what seems to be the problem here? I save this, run it again. Yeah, there you go. I didn't save it. So it will run the migrate, sorry, and then it will compile it. Now it will deploy it to the blockchain, and it will show you the final cost of deploying that contract to the blockchain and the final address of that contract. So when it's done, you get something like this, and there you go. We got the transaction hash. We could look that up later. Contract address, this is the address that you need. You are going to use this one to instantiate from this contract and interact with it. The block number, block timestamps, the contract, the account that deployed the contract. This account is going to be owner of this contract if you use the owner. So if you're going to make any crucial change that needs or any functions that has the owner modifier, this account should be the caller, because this one, when you deploy the contract, this function on the owner, the constructor, as you can see in here, this constructor gets executed, and it will set the owner, which is a storage here, or storage variable here, state variable actually, address. It will set the address to the messenger or msg.sender, which is the address or the wallet that deployed this contract. So as you can see, and then it will emit the event for the address change or the owner change. So this one is going to be owner, and this is the balance. This is the balance of the contract, I think, or the balance of this account, I'm not sure. And you can see how much gas you used and the total cost. How much did it cost for you to deploy this contract on the blockchain? So as you can see, we've just deployed our contract, and if we come in here, you can see we got a contract creation transaction in here, and if you go in it, you can see that the address. So let me grab this one. You can see that this is the same. So we got our contract deployed on the blockchain, and everything is fine to go and deep dive into the next section, which is going to be front end, and we are going to interact and actually do some changes, get some inquiries from this contract using the Web3 or Ether.js libraries from the front end. Okay guys, as I told you in the beginning, this video is going to be two parts. We've already covered the first part, that was the backend, and the second part will come out soon, so make sure you like, share, subscribe, and comment your thoughts on this video. See you soon.